Welcome to a video on sampling methods or sampling techniques. In this video, we're going to cover several different sampling techniques, weigh their pros and cons, and look at examples. Stay to the end of this video and we'll look at some sample problems to determine what sampling methods are being utilized. Let's get started. Before we get into our sampling techniques, let's take a look at where we are in the big picture of statistics. I like to call this the circle of statistics. We always start by wanting to know something about our population. Because our population usually tends to be fairly large, we'll carve out a sample. Then we use descriptive statistics to learn about your sample. Once we know about our sample, we use that sample to make inferences about our population. So statistics really relies on this step here where we carve the sample out of our population. Essentially, what we can learn about our population is going to come from our sample. So it's critical that we take our time and make sure that we collect a representative sample from our population. So the sampling techniques that you use to take a sample from your population ultimately can determine what you can and cannot learn about your population. Our goals in using sampling techniques are to choose an accurate representation of the population. We do our best to eliminate bias from sampling techniques. Sampling also saves us time and money when we're conducting a study. But there are drawbacks of using a sample. Let's be honest, all samples are different. There will always be some variability between different samples. And there's always a chance that your sample does not accurately reflect the population. But keep in mind that oftentimes our populations are just too big to access altogether. So sampling on our population is the most efficient way to learn, and the sampling technique you employ ultimately affects how accurate your information about your population can be. Throughout this video, I'm going to be using this symbolic population to demonstrate the different sampling techniques that you can employ. Notice that our population has 12 members, and they have been given a unique number between 1 and 12. But also, members belong to different groups. We have members of the blue circle group, 1, 10, and 12, the red triangle group, 2, 4, 6, 7, and 8, and the green pentagon group, which is members 3, 5, and 9. So there are characteristics of the members that are unique, but there are also things that are in common between the population. The first technique I'd like to cover is known as a census. This is where every individual of interest is measured. In other words, we use the entire population. So I guess technically this is not really a true sample because you're trying to measure all members from the population. But let's go through some pros and cons of using a census. For pros, it's a way to get a true and accurate measure of the population. Sometimes it creates what we call benchmark obtained for future studies. But there are cons. Usually the number one thing with using a census is there's a higher cost and a longer time to collect and process the results. Let's take a look at some examples of a census. Well, first of all, you may be most familiar with a population census that's taken every 10 years in the United States. This is a pretty arduous and expensive process. The census takes at least a year to prepare for, a year to collect the results, and a year to process the results. So you're looking at a 3-year period that costs several millions, if not billions of dollars. So this is why we say that the main downside of a census is that it takes a lot of time, money, effort, and energy. Another example is STAR testing that's used in K-12. This is where all students take the test and all results are analyzed. Also, colleges can report demographical information that's collected. If you remember when you applied to the institution, there was usually a separate form that they ask you to fill out that collects demographics. Those are measured from every student who completes them. And now let's talk about a random sample. A random sample is one where every member of the population has a chance of being chosen. There are several different types of random sampling methods, But the key to having a random sample is that every member of the population has a chance of being chosen. It doesn't necessarily have to be an equal chance of being chosen, but every member has to have a chance of being selected. Let's take a look at some different methods that all involve random sampling. First, let's take a look at what's known as a simple random sample, or SRS. In a simple random sample, every member of the population is assigned a number. A random number generator is used to select different members of the population. So here's my population from 1 to 12. Now, I went over to my calculator and I asked the calculator to give me 4 random numbers between 1 and 12 with no repetition. It selected 1, 9, 10, and 6. So if I was taking a simple random sample, my sample would be members 1, 9, 6, and 10. The key for a simple random sample is that it's conducted so that each member in the population has an equal chance of being selected. So there is a random sample where every member has a chance of being selected, but a simple random sample is when every member of the population has an equal chance of being selected. That's a very subtle but important difference between a random sample and a simple random sample. For a simple random sample, you can think of it as kind of like a lottery method, pulling numbers out of a hat. In fact, that's our first example. You could assign every student in the class a number and then draw numbers out of a hat. That would be a simple random sample. Every student in the class had an equal chance of being selected. Jury selection is usually one instance where they use simple random sampling. And now let's take a look at the pros and cons of a simple random sample. As a pro, it's easy to implement and analyze the results. And it usually yields a truly representative group from your population. The cons are it usually requires a really large sample size. And it can be difficult to obtain a complete list of individuals in the population. Finally, there's always a chance that some groups may not be represented. If you had a minority group that was a small part of your population, they may not get selected to be a part of the sample. So there's a chance that you would have some groups that are not always represented when you use a simple random sample. Now let's take a look at some variations on the random sample. We'll start by looking at the stratified sample. A stratified sample is when you divide the population into subgroups called strata. Then take a simple random sample from each strata. When I think of a stratified sample, I always think it's a few from all. Let me explain what I mean. Here's how a stratified sample works. You have your population, you divide your population up into strata, which are non-overlapping groups, like we can group them together by the blue circle group, the red triangle group, and the green pentagon group. These groups are non-overlapping, and then we use a simple random sample to select members of each group. So in this case, our sample is 2, 10, 8, and 5. Before we look at the pros and cons of a stratified sample, let's try to understand it better by looking at an example. One example of a stratified sample is when you divide the population into socioeconomic groups, then randomly select individuals from each group. Note that the number of members should be proportional to the overall size of each strata. In other words, you could break your population up into like a high socioeconomic status, middle socioeconomic status, and a low socioeconomic status. The nice thing about the stratified sample is that you know you would be getting members from each socioeconomic status in your sample. So it guarantees all groups are represented in the sample. So the pros of a stratified sample is that every group is represented in the sample. In fact, this is oftentimes why stratified samples are used, is when you want to ensure that every group is represented. By ensuring that every group in your population is going to be represented, you can typically use fewer subjects. There are a few cons though. It does require subgroup identification of the members. So every member has to identify with one of the groups since they do not overlap. It does require proportional distribution of the population because you're going to take a sample that's in proportion with the groups. So if you look here, there are 3 members of the blue circle group and 3 members of the green pentagon group. But we have 6 members of the red triangle group. So the red triangle group is twice as large as both the blue and green group. So in our sample, we've selected 1 member from the blue circle group, 1 member from the green pentagon, and 2 from the red triangle group. So our sample is usually proportional to how the groups are divided in the population. That can also be a pro and a con. It does require consideration for members that identify with 2 or more groups. So when you're trying to take a stratified sample, if you have one individual that identifies with, let's say, the blue circle group and the green pentagon group, they can only belong to one strata. So you either have to force the members of your population to pick one category, or you'd have to create a third grouping, which would be like the blue-green group. So remember for the stratified sample that it's a few from all, a few members of all groups. Let's contrast that with the cluster sample. The cluster sample is very similar to the stratified sample, but there is a main difference that I'll be sure to point out. In a cluster sample, you divide the population into subgroups called clusters. Then you randomly select a few clusters and measure all subjects from each cluster. So a cluster is when you take all from a few. So you start with your population and you divide that up into little clusters. In this case, I divided the population into 6 groups, each having 2 members. Usually you then label the groups, in this case 1 through 6, and then you would use a random number generator to select the clusters for your sample. So in this case, my sample, which was 2 clusters, was the group including members 5 and 6 and 11 and 12. A cluster sample is all from a few. So you sample all members from a few clusters. Whereas a stratified sample was a few members from all strata or groups. Let's take a look at an example of where a cluster sample might be useful. Let's say we wanted to study the effects of the bark beetle on a national forest. How you would use a cluster is you would divide the national forest up using some sort of grid. Each space on a grid is non-overlapping and is given a number between 1 and 30 in this example. Then use a random number generator to select several groups from the grid. Each grid that is selected is where members of this team will go out and survey the forest in that acreage. So in this case, you would look at all trees in a few clusters, but there would be many clusters where you don't even look at the trees in that cluster. Let's take a look at the pros and cons for a cluster sample. The pros are it's efficient for large populations. If you think about it, there's no way we could do a census on an entire national forest. It's way too big, would take way too much time, and would be severely inefficient. The cons are it can be difficult to get data from all members of a cluster. So similar to the stratified sample, it requires all members to be assigned to only one cluster. So if you use dividing criteria where members can identify with 2 or more groups, it can be tricky as to determine where those members get placed. Now let's take a look at what's known as the systematic sample. This is when you randomly choose a starting place, then select every kth individual to measure. Let's say we use a random number generator to determine a starting point, like say it's the number 2. We would use a process to select which member comes next. In this case, we start at 2 and we'll sample every 3rd member in the population from thereafter. So in this case, we've selected 2 and then we count 1, 2, 3. Member 5 gets selected, 6, 7, 8 will be selected, 9, 10, 11 will be selected. So systematic sample, there's a system in place on how you're selecting your sample. Let's look at an example of a systematic sample. Quality control for a cell phone manufacturer runs diagnostic tests starting with the 5th phone produced today and continuing with every 8th phone thereafter. So the starting point is the 5th phone, so we count down from the start of today's production and we find the 5th phone. From thereafter, we're going to select every 8th phone on the assembly line and run diagnostic tests on it today. So a systematic sample is really useful when it comes to quality control. When you don't have time to run diagnostic tests on every phone in this case, having a method in place that allows you to randomly select several of today's phones from the production line will allow you to determine if everything is in good working condition. Here are the pros and cons for a systematic sample. It has a very simple design. However, the cons are once the first subject is chosen, the rest of the subjects do not have the equal chance of being selected. Ideally, to get a really representative sample from your population, you want each member of the population to have an equal chance of being selected. And now let's take a look at what's known as the convenient sample. This is when researchers pick individuals to be included that are easy for the researcher to access. For an example of a convenient sample, let's say you want to know the opinion of people about the criminal justice system, and you stand on a street corner near the county courthouse and question the first 10 people who walk by. Since you're standing out front of the courthouse, most of the people that are walking by are probably affiliated with the courthouse and the judicial system in some fashion. So you may not get a representative view of the entire population. The pros of a convenient sample are that it's cheap and it's easy. You also get a high participation rate. The cons are it's usually not representative of the population. In fact, a convenient sample is not recommended because it's very difficult to generalize to other subjects in your population. Now that we've talked about all of these different sampling techniques, let's take a brief moment to talk about sampling bias. When we talk about bias in sampling, it simply means that the sample does not represent the population from which it was drawn. There are many types of biases in statistics that we'll talk about in a later video. But when you have sampling bias, so the sample does not represent the population, the conclusions from your sample may not apply to the population as a whole. Sampling biases can be anticipated or unanticipated. So if you use a convenient sample, if you survey members that are close to the researcher, you're definitely going to leave out part of your population. So you should anticipate sampling bias when using a convenient sample. That's why we encourage people not to use convenient sampling. But biases can also be unanticipated. Even though you go through and you set up a simple random sample, you may still have parts of your population that were simply left out of the sample just by random chance. Their number was not drawn. But by and large, randomization is the key to avoid bias in sampling. Let's end this video with a few examples. Let's see if we can identify each sampling technique being displayed. For these examples, we'll look at the same study but different ways of collecting data. In this study, researchers want to collect cholesterol levels of U.S. patients who had a heart attack 2 days prior. The researchers randomly select 5 hospitals in the U.S. and then measure the cholesterol levels of all of the heart attack patients from each of those hospitals. So this is all heart attack patients from a few hospitals, so this is a cluster sample. Same study, but this time the researchers list all of the heart attack patients and measure the cholesterol level of every 25th person on the list. Well, in this case, there's a system in place. Every 25th person tells me that this is a systematic sample. The researchers go to one hospital on a given day and measure the cholesterol level of the heart attack patients at that time. This is a convenient sample. They happen to pick the patients at the one hospital they're at for that day. What if the researchers list all of the heart attack patients? Then they measure the cholesterol levels of randomly selected patients. This would be just a simple random sample. What if the researchers divide the heart attack patients based on race and then measure the cholesterol level of randomly selected patients in each race grouping? So this would be a few patients from all groups. This is a stratified sample. And that's it for this video. Thanks for watching.